Let's look at Physics 1134, page N, and let's talk our way through problem 64, all right? So 64 says a warship calls in jet fighter support. If the ship's guns are firing shells with a velocity of 350 meters per second at an angle of 35 degrees, they're going to kind of go like this, hit a peak, and then come down, right? They're not going to just keep going up. So they're going to reach a peak and then crash. Question is, how low can the fighter jets come in and still remain 100 meters above the maximum height of the ship's shells? Okay, so I wrote up here already some of the information that we have and a couple of the important formulas that were already in the PACE. And so let's think through what we need to do here. We know the angle is 35, and this is like the velocity, this vector here, and we can resolve that into two vectors, the horizontal vector going this way, and the vertical vector, which is the one going up, which shows us the maximum height. That's actually what we need to figure out. What's the maximum height that the shells are going to go? So that's the VV. We really aren't going to do anything with VH for this problem. But we need to resolve this vector into the VV. And so that's the opposite. So if you remember your sine, cosine, and tangent, opposite over hypotenuse is how we find sine. So opposite over hypotenuse, in this case the hypotenuse is the velocity. And the opposite is what we're solving for, this vertical vector. So we're going to take the sine of the angle, 35 degrees, sine of 35, times the vector itself, which was given, 350, and that should give us the vertical components. We expect it's going to be something less than 350, okay? So let's figure this out. Let's plug in 350, and then plug in the sine of 35. Let me get my handy calculator up here. Make sure we're in degrees mode. 35 sine is 0.5736. All right. I'm just going to leave the whole thing on my screen. Times 350 gives me 200.75 as the vertical velocity, okay? Then to find the maximum height, and here I want you to do this last step yourself, okay? Because we're going to take this number and plug it in here, all right? And plug it in up here. So we're going to take the 200.75 divided by 9.81 and multiply 1/2 times that vertical velocity times the answer to this, and that will give you a big number, okay? We're not done then. The final question is, how high do the planes need to stay to avoid getting hit? So whatever answer you get for this, all you have to do is add 100 to that, okay? Because we want to stay 100 meters above the maximum height that the shells are coming in. All right, so I think we have enough formulas up here. We got you started with some of these numbers, seeing what we're doing with them. And if you plug that in, it's just a matter of using your calculator to get the final answer here. The last step, don't forget to add the 100. When you go to check if it's not exactly correct, it's probably because of rounding somewhere, significant figures, that kind of a thing. It's up to your supervisor whether they want you to really be super concerned about that. I'm happy if you get the right number, okay? And then if you need to go back and tweak it for sig digs, fine. But good luck. We'll come back and talk about a problem or two on page O.